Let's talk about solutions. A solution is a homogeneous mixture. Remember, that means that the mixture is the same throughout. If you could take samples from everywhere in that mixture and they would all be identical. It's important to know that in the solution there are no bonds between the substances. They're just evenly mixed. So if you have a solution of salt water, the salt and the water are not bonding together. The salt and the water are just spreading out evenly. A solution is made of a solute dissolved into a solvent. Sometimes it's hard to tell which one is the solute and which one is the solvent, but the best general rule of thumb is that there's less of the solute. Usually the way dissolving works is that the solvent particles are attracted to the solute particles, and so they pull them away from the main mass and surround them. Most of us only think of one type of solution. We think of a solid dissolved in a liquid, like Kool-Aid or like the salt water I talked about earlier. There are lots of different types of solutions. You can have a liquid dissolved in a liquid, like juice. When you make juice from concentrate using one of those cans, you have the juice in the can is the solute and the water you add is the solvent. You can also have a gas dissolved in a liquid, like soda. The carbonation inside the soda is the gas solute in the liquid solvent. You can also have a solution of gas in gas, like air. The air we breathe has oxygen in it, and it also has CO2, and also has traces of lots of different gases. So those gases that are in, those other gases in air are the solute dissolved in the solvent. Another type of solution is solid dissolved in solid. An example of this is metal alloys like brass. And an alloy is just when you mix two different types of metals to make a new metal that has slightly different properties. The final type of solution is a gas dissolved into a solid. An example of that is a marshmallow. The body of the marshmallow is a solid, but there's air pockets in them. That's why if you squeeze a marshmallow, it can get flat because you can squeeze out all the solute. When you let it go, it brings back in that gas. Some more common terms we use when talking about solutions are soluble versus insoluble. Soluble means it will dissolve, and insoluble means it will not dissolve. So, for example, we could say that salt is soluble in water because salt dissolves into water. We can also say that rocks are insoluble in water because if you put a rock in a glass of water, it's not going to dissolve. Another pair of terms is miscible versus immiscible. Immiscible means mixable, they will mix. And immiscible means they will not mix. So these terms mean very close to the same thing, but miscible and immiscible are typically used when talking about liquids. So your juice concentrate and your water are miscible, and oil and water are immiscible. They will not mix. We can talk about a solution's concentration, and that just describes how much solute is dissolved. You can actually calculate a number for concentration, which you'll do in chemistry, but we're just going to talk about it qualitatively. We're going to use it to compare. So a concentrated solution has a lot of solute, and a dilute solution has less solute. Let's talk about that juice again. In the can, it's called from concentrate, right? It's the concentrated juice. And when you add water to it, you make a more dilute solution. We can also talk about how saturated a solution is. A saturated solution is full. It cannot dissolve any more solute. So all the space is taken up. They cannot put any more in. If you add more, it's just going to pile up at the bottom. An unsaturated solution means it's not full. You could add more solute and it will continue to dissolve. A supersaturated solution is more than full. So it has more solute dissolved in it than should have at that temperature. One way to make a supersaturated solution, if you've ever made rock candy, you make a supersaturated solution of sugar water. You heat up the water, and when you heat something up, it can dissolve more. So you heat up the water, and it's able to dissolve more sugar. And at that point, it's just saturated. It's not supersaturated yet, because that's how much solute it should dissolve at that temperature. But if you cool the water down, as the water cools, it becomes a supersaturated solution, because it's still holding all that sugar it dissolved when it was hotter, but now it's cooled off. And if you have a supersaturated solution, you can make the excess solute come out, like when you make rock candy, in a couple different ways. One is by providing something for it to grow on, like the stick or string if you make rock candy. Another is by giving it a seed crystal, like one little piece of crystal. If you had that supersaturated solution of sugar water and you dropped in some sugar, more sugar would come out of the water and cling together. So what kind of solution is this? And you can actually tell by looking at it. Because there is solute at the bottom, we know that this is a saturated solution, because it cannot dissolve anymore. If it was unsaturated, there wouldn't be any solute at the bottom, because it could still dissolve it. If it was supersaturated, you still wouldn't see the solute at the bottom, because it would all be in the liquid. When you make a solution, the solvent particles use their attraction to solute particles to pull them away from each other. And the more often and faster the solvent particles hit the solute particles, the faster the solution dissolves. So to make a solution dissolve faster, you can do three things. You can increase the surface area. That means have more of the substance be on the surface. And generally increasing the surface area means making a smaller particle. So ground sugar has much more surface area than a sugar cube, because almost all of the sugar is on the surface because the particles are so tiny. Whereas in a sugar cube, there's a lot of sugar away from the surface of the cube. So if you increase the surface area, it dissolves faster because more solute is in contact with solvent at any time. You can also increase the temperature. Increasing the temperature causes particles to move faster. So when they move faster, they bump into each other more. The last way to make a solute dissolve faster is agitation. That means shaking it or stirring it. And if you stir it around, not only do you make the particles move faster, but you get the solvent particles that have taken out solute, and you move them away so that there's fresh solvent particles to attract more solute away. It's important to know that you cannot make something dissolve faster by adding more solvent. If you're trying to dissolve sugar into your coffee, adding coffee to it does not make it dissolve faster. A similar topic that gets confusing sometimes is how can you make more dissolve? I want to know how to make the sweetest sweet tea ever. So we have to talk about solubility. Solubility tells you how much will dissolve. To increase solubility, you can increase the temperature. That's why a lot of people in the South, when they make sweet tea, add the sugar when the tea is hot, because it will dissolve more sugar when it's hot, and it makes the tea sweeter. The exception to this is gases, because like a soda, if you increase the temperature, the gas solute moves faster. And when the gas particles move faster, a lot of times they leave the solvent because they want to go further away. So for a gas, increasing the temperature actually decreases the solubility. It's the one exception. You can also increase pressure, especially if you're talking about gases, to increase solubility. Again, like that soda can. You've noticed if you open a can of soda and just leave it, even if you don't shake it, you just leave it sitting on the table, it will get flat because the pressure is much lower with that can open, and the carbonation eventually leaves the solution. I want to take a minute and look at an example of a solubility curve, because you're going to see these, and I don't want them to be confusing to you. If you read these, It just shows you, it says how many grams of solute can be dissolved for every 100 grams of water. And you can see down this side is temperature. So if you read it, at 10 degrees Celsius, about 8 grams of KClO3 can be dissolved in every 100 grams. And 18 and 20, you just read it up. Now you should be able to look at this graph and tell lots of different things. Even though there's a key over here that tell you gases have dashed lines, you should actually be able to look at it and know. Because remember I said gases are the only thing that gets less soluble as the temperature increases. And you can see that HCl can dissolve about 78 grams for every 100 grams of water at 10 degrees, but only 45 at 90 degrees. So that solubility is decreasing. And the steeper the line is, the more it increases or decreases.